Hey everybody, this is a short video to address a couple things I feel like I missed in the video for homework 2, which was quadratic equations, factoring, and rational equations. The one thing I missed was solving square root equations, and then on the next page, there's some examples of one other thing that I didn't do well. So solving square root equations, there's a couple things to be aware of. The first step is typically that we want to isolate the square root so that we can square both sides and have the radical go away. So I'm going to subtract it from both sides and get the square root of 3x plus 4 equal to x minus 2. Then I'm going to square both sides. You could probably skip this step, square root of 3x plus 4 squared equal to x minus 2 squared. A square root squared always just becomes the argument. So we're going to get 3x plus 4. X minus 2 squared is really x minus 2 times x minus 2. And we fill all that out, we get x squared minus 2x plus 4, which ends up being x squared minus 4x plus 4. We bring everything to one side. I'm always a fan of bringing things to the side where the coefficient of the highest power of x is positive. So I would bring everything to the right-hand side. So I'm going to say that we have 0 on the left, x squared on the right, minus 4x minus 3x is minus 7x. 4 minus 4 is 0. So I'm not even going to write that. Factor, whichever side makes sense to factor. So I'm going to have 0 equal to x factored out times x minus 7. So then we get two potential solutions, x equal to 0 or x equal to positive 7. And then we do have to check for extraneous solutions because when we square both sides of an equation, it's possible that you have something like negative 5 equals 5 and you square both sides, you get 25 equal to 25, which seems right, but if you go back to the original, actually isn't. So we're going to check both. If we plug in x equal to 0, let's see what happens. Here we're going to get the square root of 0 plus 4, so we're going to get the square root of 4 plus 2 equal to 0. Doesn't work. 2 plus 2 doesn't equal 0. So x equals 0 is not a solution. If we plug in x equal to 7, we're going to get the square root of 21 plus 4 is 25 plus 2, and that equals x, which is 7, and that works out because 5 plus 2 is 7. So that checks out. So the only solution here is x equal to 7. And you always have to check all the solutions every time for a square root equation like this because both solutions can be correct, or I should say, all the solutions, there could be more than two, but usually there's two. All the solutions can be correct, or some of them could be correct, or none of them could be correct. So knowing that x equals 0 wasn't a solution, we still had to check x equals 7. Let's look at this next one. So we have the square root of 2x minus 8 plus 7 equal to x plus 3. We're going to start off the same way by isolating the radical. So the square root of 2x minus 8 equal to x plus 3 minus 7. 3 minus 7 is minus 4. And then we're going to square both sides. That's probably fine just to slap on a square to both sides here. So squaring both sides, the left-hand side is going to be just 2x minus 8. The right-hand side is going to be x minus 4 times x minus 4 is x squared plus 2 times x times negative 4 if you want to think of it that way, or just minus 4x, which is minus 8x. And then negative 4 times negative 4 is positive 16. Again, bring all the terms to one side. I'm going to bring them to the right-hand side. So I'm going to say that 0 on the left-hand side equals x squared minus 8x minus 2x is minus 10x. And 16 plus 8 is plus 24. It would also be totally fine to write this on the left-hand side. I could have written x squared minus 10x plus 24 equals 0. Same difference. Typically, these will factor because they're designed to be not terrible. So we factor the right-hand side, we get 0 equal to, I think the numbers that multiply to 24 and add to negative 10 are negative 4 and negative 6. So the potential solutions are x equal to positive 4 or x equal to positive 6. We're going to check them. So if we plug in x equal to 4 to the original equation, it has to be the original, or at least really has to be before you square both sides. And by plugging 4, I get the square root of, let's see, 2 times 4 is 8. 8 minus 8 is 0. So the square root of 0 plus 7. Is that equal to 4 plus 3? Yes, it is. 7 equals 7. Cool. And then if we have the other potential solution, which is x equal to 6, Plug that in, I get 2 times 6 is 12. 12 minus 8 is 4. So the square root of 4 plus 7, is that equal to 6 plus 3? And it is. 2 plus 7 is 9. 6 plus 3 is 9. So here, both are solutions. So my solutions are x equal to 4 and 6. I will point out, just looking back at this previous one for a second here, if you were to plug in 0 to both sides of this, so here it kind of seems kind of weird, like why would 0 potentially work? But if you look here on the left-hand side, the square root of 0 plus 4 is the square root of 4, which is 2. And over here, 0 minus 2 is negative 2. And while those certainly aren't equal to each other, if you square both sides, 2 squared is positive 4, and negative 2 squared is positive 4. You can see why that's looking like it could have been a solution. So that's why we call it an extraneous solution. It's a solution of the equation once you've squared both sides, but it's not a solution to the original equation. So that's how you deal with square root equations. You isolate the radical, you square both sides, you solve for x, typically by factoring a quadratic, and then you test all of your solutions in the original equation to make sure that they're actually solutions and not extraneous. And the other topic I wanted to address was the quadratic u-substitution using specifically examples where you have to use the quadratic formula. So the one example I gave in the other video was kind of not nice in that it didn't actually have any solutions, which just felt disappointing. So I have a few examples here where we actually are going to get some solutions. So here, I would choose to do the u-substitution, and I would let u equal x squared. And I'm always picking the power of x that's closer to 0, usually smaller or less negative if we have negative powers. And then the square of that should be the other power that's in your equation. So u is x squared, and u squared is x squared squared, which is x to the fourth. There's my x to the fourth, there's my x squared. So I'm going to rewrite this as u squared minus 10u plus 18 equals 0. And then you might notice that this doesn't factor. There aren't any numbers that multiply to positive 18 and add up to negative 10. I should say that statement is not entirely true. There aren't any integer numbers that multiply to 18 and add up to negative 10. There are irrational numbers that actually satisfy that. So we're going to solve this by using the quadratic formula. So we're going to say that u is equal to negative b, which is negative 10. I'm not going to write out the formula. It's available. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I didn't write them out. B here is negative 10, a here is positive 1, c here is positive 18. Simplifying this, we get 10 plus or minus the square root of 100 minus 4 times 18 is, let's see, 2 times 18 is 36. 36 times 2 is 72. So we get 100 minus 72, all divided by 2. That's going to be equal to 10 plus or minus the square root of, let's see, 100 minus 72 is 28, all divided by 2. 28 does have a square factor of 4, so we're going to get 10 plus or minus the square root of 4 times 7 is 2 times the square root of 7. All divided by 2. Divide each term by 2, and you get 5 plus or minus the square root of 7. And then we say, well, that's what u is supposed to equal, but then u is really x squared, so we're going to say that x squared is equal to 5 plus or minus the square root of 7, and then we're going to square root both sides. It's important to think about whether or not this is positive or negative. Certainly 5 plus root 7 is positive. 5 minus root 7 is also positive because 5 is bigger than the square root of 7. 5 is the square root of 25, and the square root of 7 is smaller than that. So we get x equal to plus or minus the square root of 5 plus root 7, and we get x equal to plus or minus the square root of 5 minus root 7. All 4 solutions here. Similar idea here. We're going to first bring everything to one side. So we get x to the 6th plus 4x cubed minus 2 equal to 0. We're going to let u equal x cubed. U squared is x cubed squared, which is x to the 6th. So this becomes u squared plus 4u minus 2 equals 0. We're again going to use the quadratic formula because there aren't numbers that multiply the negative 2 and add to positive 4. So we're going to get u equal to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 2, all divided by 2 times 1. Simplifying, we get negative 4 plus or minus the square root of 16 plus 8 is 24, all over 2. 24 is equal to 4 times 6, so that's the square root of 24 is the square root of 4 times 6, or 2 times radical 6. So that's going to be negative 4 plus or minus 2 radical 6, all over 2. Dividing each of those numerators by 2, we get negative 2 plus or minus radical 6. And that's what u is equal to. So that's what x cubed is equal to. So we have x cubed equal to negative 2 plus root 6, and x cubed equal to negative 2 minus root 6. Here, it doesn't actually matter whether negative 2 plus root 6 or negative 2 minus root 6 is positive or negative, because you can take the cube root of any positive or negative number. Negative 2 plus root 6 is positive because the square root of 6 is bigger than 2. Negative 2 minus root 6 is clearly negative because it's a negative number minus a number. So here we're going to get x equal to the cube root of negative 2 plus root 6. Here we're going to get x equal to the cube root of negative 2 minus root 6. It's not a plus or minus because we have it's a cube root. Odd roots don't get a plus or minus. I'll pause this for just a second. Last example. So same idea here. We're going to bring everything to one side. X to the 8th plus 2x to the 4th minus 2 equal to 0. It has the usual hallmark of being a quadratic u-substitution in that you see x to a power and x to twice that power. So we're going to let u equal x to the smaller power. And again, I really should say the power that's closer to 0, because if your powers were like negative 2 and negative 1, you would pick u equal to x to the negative 1, which is closer to 0 than negative 2 is. U squared is x to the 4th squared, which is x to the 8th. This becomes u squared plus 2u minus 2 equal to 0. Once again, this doesn't factor. There aren't numbers that multiply the negative. There aren't nice integer numbers that multiply the negative 2 and add up to positive 2. So we're going to use the quadratic formula. We're going to get u equal to, there's our b. In fact, you can write this out. I don't like to. It's not that I don't like to. I just don't like to take the time to. A is 1, b is positive 2, c is negative 2. So we're going to get u equal to negative b plus or minus the square root of b squared minus 4 times a times c. You don't have to write all this out if you know that negative 4 times 1 times negative 2 is positive 8, but it's good to write it out so you don't make a mistake. Over 2 times 1, it simplifies as negative 2 plus or minus the square root of 4 plus 8 is 12, all over 2. This simplifies further as negative 2 plus or minus 2 root 3, all divided by 2, because, right, 12 is 4 times 3, square root of 4 is 2. And then finally, dividing each thing by 2, you get negative 1 plus or minus the square root of 3. And here's where we have to be extra careful. So that's what u is equal to. And then we're going to write that x to the 4th, which is what u is equal to, is negative 1 plus root 3. And x to the 4th is negative 1 minus root 3. Negative 1 plus root 3, is that positive or negative? Well, the square root of 3 is bigger than 1, so negative 1 plus the square root of 3 is positive. And we can always take the 4th root of a positive number. So here we're going to get x equal to plus or minus, because it's an even root, not an odd root, the 4th root of negative 1 plus root 3. You could have also written this as root 3 minus 1, which is probably how most people would write it, because we usually write the positive thing before the negative thing if we have a choice. And I'm boxing this because I already know the other part of the answer is not going to be part of the answer. If we try to go here, negative 1 minus root 3 is clearly a negative number. And you can't take an even root of a negative number and get a real result. So if we try to do that, x equal to the 4th root, I should say plus or minus the 4th root of negative 1 minus root 3, this is not real. It's a complex or imaginary number, and we don't consider those, at least currently. So our only solution here would be the plus or minus 4th root of negative 1 plus root 3, because this is the only one where we're taking the even root of a positive number. So if you're doing a quadratic u-substitution, and you have your u equal to x to an even power, you have to be extra careful when you're determining what your solutions are. If that u is equal to something negative, then an even root of a negative number isn't going to be a real number, whereas an even root of a positive number is totally safe. All right, that's all for that. I just wanted to give you a quick few examples to make sure that that all seemed clear as possible.